Okay, so let's go through the trials of three gravitational question from Raffles, right? Okay, so we have this planet has a radius of about 1,150 kilometer, and we are given the gravitational potential graph. Also, you can see it's a negative graph. Okay, so for the very first part, they say explain why the gravitational potential has a negative value. Okay, so how do we actually explain this question? About 2 marks, right? Normally it's 2 to 3 marks lah. For this question it's 2 marks. Okay, the first part you say that G force is an attractive force, hence the work done by external agent. So remember external agent, right? It's just a like invisible hand like that, to bring a unit mass, meaning 1 kg mass from infinity to a point in space, right, is always negative. Because gravitational potential is actually a work done by external agent. Because why? Because the direction of force and the direction of displacement is always opposite. So you just say that, the third point, you just say gravitational potential is defined to be 0 at infinity. Okay, so let me just recap lah. Why is it always negative, right? Okay, first we have Earth, we have a 1 kg mass at infinity. So apparently, right, you can see that the Earth exerts a G force on the 1 kg mass, meaning it's towards the left hand side, right? Okay, then after that, right, in order to bring this 1 kg mass to this point P, so let's just say I say, this is point P, I need to exert a force in a particular direction. But of course, you remember that the definition is that I must ensure that the mass does not change. I mean, the acceleration of the mass does not change, meaning the A is equal to 0. Means that there shouldn't be any resultant force acting on this 1 kg mass. So that's why my force by external agent must point towards the right hand side. So this actually will, this will actually cause this force of external agent to be right hand side, and I want to displace the 1 kg mass, right, to the left hand side. So of course you can see that my work done. Okay, work done equation or formula, right, is force times distance. The full formula is FD cosine theta. So what is the theta? The theta actually is the angle between the force by external agent and the displacement. And of course you can see it's 180 degree, right? So if you submit 180 cosine 180, you should be able to get negative value. Alright, so okay, let's move on to part B. Okay, part B, draw a tangent at about 2,500 kilometers. So just roughly draw a tangent right here. Okay, for part 2, the gradient of the tangent represents the magnitude of some vector quantity. State what is this vector quantity. So you simply just put G field strength. Okay, part 3, we are asked to calculate the gradient and hence put the SI unit, right? Okay, very simple. Your gradient should be roughly 0.133. But of course you will not get exactly 0.133 because the tangent that we draw is actually different. So as long as you are able to get roughly from 0.maybe 125 to maybe 0.140, I think that will be acceptable. Okay. So okay, for part C, use the graph of the figure, right, to determine the escape velocity at the surface of the planet. So to determine escape velocity, you need to use something called the PCOE, the principal conservation of energy. So meaning that, okay, you start at the surface, meaning that this is point 1, right? So at surface, you possess kinetic energy. So this kinetic energy is something that the object must possess in order to move to infinity. So KE1, of course, there's one more is GPE1. When you move to infinity, there's also energy, but the total energy of K2 plus GP2 must be equal to 0. Because at infinity, there shouldn't be any energy. Okay, so at the surface, half mv squared plus negative GMM over R is equal to 0. So you just need to manipulate. So for example, I move this negative GMM over R to the right hand side. So you get positive right here. So you just do the cancellation of M. Then after that, V squared equal to 2gm over R. What is the escape velocity? So this V right here is the escape velocity. So escape velocity is equal to square root of 2gm over R. And you recognize one thing is that, my gm over R is actually your gravitational potential. So since you started out at the surface of the Earth, right? So we go back to the graph. So you started at the surface of Earth, you simply just use negative 0.77 because you realize that the graph actually started at here. So it's about negative 0.77. Since it's a megajoule per kg, right, just times 10 to the power 6. So you ignore the negative sign, just put the number, right? So what you get is 0.77 times 10 to the power 6. But don't forget there's a 2 in front, means you need to times 2, right? So you just need to do the square root of 1540,000. What you will get is roughly 1240. So your escape velocity is roughly about 1240 meter per second. Okay, with this, I'll move on to the very last part. Okay, the very last part is a bit tricky. So an object of mass 20 kg, right, is projected from the surface and reaches a point 3,500 km from the center of the planet at the highest point of the trajectory. So it means that when you shoot it to the highest point, the thing shouldn't have any kinetic energy. So this is not the satellite revolving around the planet. This is just like, maybe you shoot an object to the highest point. When you reach the highest point, there shouldn't be any speed. So you reach the highest point, of course, eventually you will go down. Okay, so that is the tricky part. So the KE plus GP is K is 0. Then GP is negative GMM over R. And we need to determine where is the point that we are interested in. So since it's about 3,500 kilometer, I need to go back to the graph. So it's roughly here. So 3,500 is this point, and if you look at the graph, it's roughly about negative 0.26 times 10 6. So that is the gravitational potential at 3,500 kilometer. So let me just write down on this, right? Okay, so negative GMM over R, right? So it's negative GM over R. You multiply by M. So this whole thing right here is the negative 0.26 times 10 to the power 6. As seen from the graph, right? What about the small m? The small m here is about 20 kg. So you just need to do the multiplication. You should be able to get a total energy of roughly, okay, it's about negative 5.2 times 10 to the power of 6 joule. So the total energy is negative. Why is it negative? Because remember, as long as your total energy is negative, means that this thing is not free, it's being bounded. It's being trapped by the planet G field. So that is how we actually do this Try Yourself 3 Raffles Institution 2013 question.